February 1st, 1943. 14:37 hours. 21,000 feet above Tunisia, North Africa. Second Lieutenant Kendrick R. Bragg felt the B-17 shudder violently as 20mm cannon shells tore through the fuselage behind him. The sound was like hammers striking metal, a rapid-fire percussion that every bomber pilot learned to fear. Through his cockpit window, he could see the Messerschmitt Bf 109 breaking away after its attack run, smoke trailing from its guns, the German pilot already positioning for another pass. Fighters. 6 o'clock high. Tail Gunner Staff Sergeant Joe C. James's voice crackled through the intercom, urgent but controlled. 3 more coming in. I'm engaging. Bragg's hands tightened on the control yoke of the B-17F Flying Fortress nicknamed All-American. Around him, 24 other bombers from the 97th Bombardment Group maintained formation, their collective defensive firepower the only thing keeping German fighters from picking them off one by one. They had just completed their bombing run on a German airfield near Bizerta, and now they faced the gauntlet of getting home through skies thick with Luftwaffe interceptors. The formation had already lost 2 bombers. Bragg had watched them go down, one with engines burning, spiraling toward the desert below. The other had simply exploded when a 20mm shell found its bomb bay. 20 men gone in seconds. The mission had been costly, but they had hit their target. Now they just had to survive the next 200 miles back to base. What Second Lieutenant Bragg didn't know, what none of the crew aboard All-American could have known as German fighters swarmed around them like angry hornets, was that in approximately 90 seconds, their aircraft would sustain damage so catastrophic that every aviation engineer who later examined it would declare survival impossible. The B-17 would lose its tail, or nearly lose it, severed almost completely from the fuselage by a collision that should have destroyed both aircraft instantly. And then, impossibly, All-American would keep flying. For 200 miles. With the tail hanging by a single structural spar. With 600 bullet and shrapnel holes. With systems destroyed and control surfaces barely functioning. The bomber would stay in the air through a combination of Boeing engineering genius, crew skill, and pure stubborn refusal to acknowledge that by all laws of physics and aerodynamics, it should be falling in pieces across the Tunisian desert. This is the story of the bomber that wouldn't die. The story of how 10 men flew a destroyed aircraft 200 miles when survival should have been impossible. The story of why German pilots who attacked it couldn't believe what they were seeing. And the story of how Boeing's engineers had built a machine so tough, so redundant, so over-engineered that it could absorb damage that would obliterate any other aircraft and still bring its crew home. The attack that would nearly destroy All-American began at 14:38 hours when Oberfenrich Hans Berthel of Jagerschwader 53 spotted the American formation from 5,000 feet above. Berthel was a veteran with 12 kills, an experienced fighter pilot who understood bomber formations and how to break them. He studied the Americans for 30 seconds, noting their tight defensive formation, identifying the lead aircraft, calculating the best approach angle. Achtung, Horst Dreh here. Berthel transmitted to his squadron. I see approximately 25 American heavy bombers, heading northwest, altitude 6,000 meters. They've completed their attack and are withdrawing. We have fuel for one attack run, then we must return to base. Make every shot count. Attack from 6 o'clock high, break low. Execute now. 11 Messerschmitt Bf 109s dove toward the bomber formation like falcons stooping on prey. The Germans had perfected this attack pattern through 3 years of warfare. Approach from behind and above where bomber defensive fire was weakest. Fire from 300 meters, where your cannon were effective but bomber machine guns lost accuracy. Aim for engines or cockpit. Break away fast before defensive fire could track you. But American bomber crews had learned their own lessons. The B-17's defensive armament was designed specifically to counter this tactic. 10. 50 caliber machine guns positioned to create overlapping fields of fire. Tail guns covering the 6 o'clock position. Waist guns covering the beam. Top turret and ball turret covering high and low approaches. A properly flown formation of B-17s created a wall of 50 caliber fire that German fighters had to penetrate, and many didn't survive the attempt. At 14 hours 38 minutes and 45 seconds, the first Messerschmitt opened fire on All-American from 400 meters, its two 20mm cannons and two 7.92mm machine guns sending a stream of shells and bullets toward the bomber's tail section. Staff Sergeant James in the tail turret returned fire, his twin .50 calibers hammering, tracer rounds reaching out toward the approaching fighter. The Messerschmitt's cannon shell struck All-American's fuselage with devastating effect. 20mm high-explosive shells punched through aluminum skin like it was paper, detonating inside the aircraft, sending shrapnel through systems and structure. The first shells hit near the tail, walking up the fuselage as the fighter closed range. James felt impact shudder through his turret mounting. His guns continued firing, tracking the Messerschmitt as it closed to 200 meters. At that range, the Germans' 20mm cannons were lethal, each shell carrying enough explosive to destroy critical components or kill crew members. Then everything went wrong in ways no one could have predicted. At precisely 14 hours, 38 minutes and 52 seconds, a second Messerschmitt dove toward All-American from a slightly different angle, firing as it approached. This fighter, flown by Unteroffizier Kurt Weber, had aimed for the bomber's tail section, intending to destroy the tail guns and then work forward, standard Luftwaffe doctrine. But Weber's approach angle was steeper than Berthel's, his dive faster, his trajectory intersecting the bomber's flight path in a way that left him no margin for error. Weber's cannon shell struck All-American's tail, destroying the horizontal stabilizer's left half, severing control cables, and shredding the vertical stabilizer. The damage was catastrophic but not immediately fatal. B-17s had survived similar tail damage before. The robust structure and redundant controls meant that even with the tail section heavily damaged, the bomber could potentially remain controllable. But Weber had misjudged his dive angle and closure rate. At 14 hours, 38 minutes and 54 seconds, traveling at over 400 miles per hour, his Messerschmitt Bf-109 struck All-American's tail section. The collision was apocalyptic. The Messerschmitt's left wing struck the B-17's fuselage just forward of the horizontal stabilizer. The fighter's wing sheared off instantly, the impact generating forces that exceeded any design parameters either aircraft had been built to withstand. The Messerschmitt tumbled out of control, spinning wildly, its pilot killed instantly by G-forces that snapped his neck before he could process what had happened. But the damage to All-American was even more catastrophic and somehow, impossibly, survivable. The collision severed All-American's tail section almost completely. The entire rear fuselage from just behind the waist gun positions to the tail was hanging on by a single structural member, the bottom keel beam, one of the main longitudinal spars that ran the length of the fuselage. Everything else had been destroyed or severed. The top structural members were gone. The side structural members were gone. Control cables were severed. Hydraulic lines were cut. Electrical systems were destroyed. The tail section, weighing approximately 800 pounds and including the horizontal and vertical stabilizers and tail gun position, was hanging from the main fuselage by a keel beam approximately 4 inches by 3 inches in cross-section. The tail was angled downward approximately 20 degrees from its normal position, creating tremendous drag and completely destroying normal aerodynamics. Staff Sergeant James in the tail gun position died instantly in the collision. The impact forces, combined with the structural failure all around him, killed him before he could comprehend what had happened. His body remained in the tail turret, in the section that was now barely attached to the aircraft. In the cockpit, Second Lieutenant Bragg felt the collision as a massive impact that threw him forward against his shoulder harness hard enough to bruise ribs. The control yoke jerked in his hands. The aircraft yawed violently to the right. Every warning light on the instrument panel illuminated simultaneously. Jesus Christ! Co-pilot Second Lieutenant Godfrey Engel's voice was high with shock. What was that? We've been hit. Engines 2 and 3 are showing temperature spikes. Hydraulic pressure is dropping. We're losing. Get a damage report. Bragg's command cut through the intercom chaos. All positions report. What's our status? The responses came back in rapid succession, each one adding to a picture of catastrophic damage. Navigator Second Lieutenant Robert Dunleavy. Navigator here. We took impacts all along the fuselage. I've got shrapnel holes everywhere. The radio compartment is destroyed. I can see daylight through the fuselage walls. Bombardier Second Lieutenant John C. O'Neill. Bombardier. The nose section is intact, but I can see massive damage amidships. There's a Messerschmitt wing section embedded in our fuselage. Top turret gunner Technical Sergeant Michael Zook. Top turret. Sir, you need to hear this. The tail section is nearly severed. I can see it through the fuselage. It's hanging on by what looks like one structural beam. The tail is bent down at an angle. Sir, how are we still flying? Bragg processed this information in seconds, his mind racing through implications. Tail nearly severed. That meant control surfaces were probably barely functional. They were still flying, which meant the main wing was intact and engines were running. But with the tail damaged and hanging at an angle, every aerodynamic calculation was wrong. The aircraft should be uncontrollable, tumbling, falling. Yet they were flying. Somehow, impossibly, All-American was maintaining altitude and heading. Engel, I need full power on all engines, Bragg ordered. We're going to have serious drag from the damaged tail. I don't know how bad control authority is yet, but we need every bit of power to stay airborne. Roger that. Engel advanced all 4 throttles to maximum continuous power. The 4 right are 1820 radial engines, each producing 1,200 horsepower, responded immediately. The B-17 accelerated slightly despite the massive drag from the damaged tail section. Bragg tested the controls carefully. The control yoke moved, but the aircraft's response was sluggish and wrong. Moving the yoke right produced a slow, mushy roll. Moving it left produced almost no response. Elevator control was nearly non-existent. The aircraft wanted to pitch nose down, requiring constant back pressure on the yoke to maintain level flight. Co-pilot, I need you on the controls with me, Bragg said. This is going to take both of us. The control forces are all wrong, and we're barely getting response. Both pilots pulled back on their yokes, fighting to keep the nose up, to maintain altitude, to keep the aircraft flying despite damage that should have made controlled flight impossible. Behind them, Technical Sergeant Zook stood in the fuselage looking aft at damage that defied comprehension. The entire rear section of the aircraft from just behind the waist gun positions was hanging at an angle. He could see daylight through the gaps where the fuselage structure had been torn apart. The tail section swayed and vibrated in the airstream, held by a single structural beam that looked far too small to bear the loads being imposed on it. Control cables that should have run from the cockpit to the tail control surfaces hung severed and useless. Hydraulic fluid leaked from ruptured lines, forming a mist in the slipstream. Electrical wiring hung in tangles, sparking occasionally where bare wires touched metal. The fuselage skin was shredded, with hundreds of holes from cannon shells, machine gun bullets, and shrapnel from the collision. And somehow, the aircraft continued flying. Zook moved carefully through the fuselage, checking on the other crew members. Waist Gunner Staff Sergeant Elton Conda and Staff Sergeant Art Benko were shaken but unhurt, their positions having been just forward of where the collision had occurred. Ball Turret Gunner Staff Sergeant Sam Sarpoulos had climbed out of his position, unable to continue operating in the damaged aircraft. James? Zook asked, though he knew the answer. He's gone, Conda said quietly. He didn't suffer. The impact killed him instantly. Radio operator Technical Sergeant Harry Newsell emerged from the destroyed radio compartment. Radio is completely destroyed, he reported. We have no communications with anyone, but I salvaged the first aid kit and some emergency equipment. Bragg's voice came through the intercom. All crew, listen up. We've sustained catastrophic damage, but we're still flying. The tail section is nearly severed, but it's holding on. We're approximately 200 miles from base. I don't know if this aircraft will hold together that long, but we're going to try. Everyone stay at your positions, keep watching for fighters, and monitor for any additional structural failures. If I give the bailout order, you go immediately. Understood? Affirmatives came back from each crew position. The men understood the situation. They were flying in an aircraft that shouldn't be capable of flight, that could break apart completely at any moment, but for now it was staying in the air. Their only choice was to ride it as far as it would go and hope it lasted long enough to get them home. At 14:45, 7 minutes after the collision, the remaining German fighters broke off their attack and turned back toward their base, low on fuel and ammunition. Oberfinrich Berthel had seen the Messerschmitt collide with the American bomber, had seen the bomber's tail nearly severed, and had assumed it would fall within seconds. When it didn't, When it continued flying in formation despite damage that should have been instantly fatal, he didn't believe what he was seeing. "Horse Dray to all aircraft," Berthel transmitted. "Did you see that? The American we hit. Its tail is nearly torn off. How is it still flying? That's impossible." Horst Funf confirms. Another pilot responded. "I saw the collision. I saw the tail section hanging. That aircraft should have fallen immediately. American construction must be extraordinarily strong. Or the pilots are extraordinarily skilled," a third pilot added. "Either way, they deserve respect. That crew is flying a dead aircraft through pure willpower." The German fighters turned away, returning to base, leaving All American and its crew to face a new challenge, surviving the 200-mile flight home in an aircraft that was barely holding together. All American's flight back to base became a minute-by-minute struggle against physics, aerodynamics, and structural failure. Every moment the aircraft stayed in the air was a moment it shouldn't have survived. Every mile covered was a mile that exceeded what should have been possible. At 14:50, 15 minutes after the collision, Navigator Dunleavy calculated their position and gave Bragg a course to their base at Biskra, Algeria. The heading required a 15-degree turn to the right. Bragg attempted the turn carefully, not knowing how the damaged aircraft would respond to control inputs. The B-17 turned, but the response was wrong in every way. The nose wanted to drop. The aircraft wanted to roll beyond the intended bank angle. Bragg and Engel fought the controls, both pilots pulling back on their yokes, coordinating their efforts to keep the turn shallow and controlled. "This is like flying a truck with 3 wheels," Engel said through gritted teeth. Every control input produces unexpected results. The tail being at that angle is destroying all normal aerodynamics. "Then we adapt," Bragg replied. "We figure out what this aircraft wants to do, and we work with it instead of against it." "Trim?" "Trim is barely responsive. I'm working it constantly, but getting minimal effect. Most of the trim cables probably run through the damaged section." At 1500 hours, the formation leader's B-17 pulled alongside All American, close enough that the crews could see each other through cockpit windows. The lead pilot's expression was one of shock and disbelief. He could see All American's tail section hanging at an angle, see the massive damage along the fuselage, see the hundreds of bullet and shrapnel holes. The lead pilot made hand signals. "Can you make it? Do you need us to slow down?" Bragg gave a thumbs up, signaling they would continue, though he had no confidence the aircraft would hold together for another 150 miles. But slowing the formation would put everyone at risk from fighter attack. Better to continue at formation speed and hope All American could maintain it. At 15:15, 45 minutes after the collision, Technical Sergeant Zook reported increasing vibration in the rear fuselage. "Sir, the tail section is moving more. The swaying is getting worse. I can hear metal grinding. The structural beam holding it is under tremendous stress." "Can you see any additional failures?" Bragg asked. "Negative. But sir, that beam is only about 4 inches across. It's holding up 800 pounds of tail section plus all the aerodynamic loads from the airstream. I don't see how it's not failing." "Boeing Engineering," Bragg replied, trying to project confidence he didn't feel. "The B-17 is built stronger than we know. That beam is probably rated for loads 10 times normal. It's stressed, but it's holding." What Bragg didn't mention was his own amazement that the aircraft was still flying. As a pilot, he understood aerodynamics, understood how aircraft structures worked, understood that what they were experiencing shouldn't be possible. A tail severed from the fuselage except for one structural beam shouldn't continue functioning. The control surfaces shouldn't be working at all. The aircraft should be tumbling or spinning. Yet All American continued flying, maintaining altitude, maintaining heading, staying with the formation. It was a testament to Boeing's engineers, who had designed the B-17 with massive structural redundancy, with multiple load paths, with a philosophy that the aircraft should survive damage that would destroy lesser bombers. The B-17's design included multiple longitudinal keel beams running the length of the fuselage. When the collision destroyed most of the rear structure, one bottom beam remained intact. That beam, designed to carry a fraction of the total structural load, was now carrying everything. It was stressed beyond its design limits, flexing and groaning under loads it was never intended to bear alone, but it was holding. The control cables that somehow still connected cockpit to tail control surfaces were routed through the lower fuselage, protected by structure that had survived the collision. Most were severed, but a few critical cables remained functional, giving the pilots minimal control authority. And the tail itself, though hanging at an angle, was still generating some aerodynamic forces. Not normal forces, not the stabilizing forces it was designed to provide, but enough to give the pilots something to work with, enough to make controlled flight possible, if not easy. At 15:30, 60 minutes after the collision, the formation crossed from Tunisia into Algeria, passing over Allied-held territory. The immediate threat of German fighters diminished, though the crew knew they still had to reach base and somehow land an aircraft that was barely controllable in the air and would be nearly uncontrollable during landing approach. Bombardier O'Neill climbed back through the fuselage to survey the damage firsthand. What he saw made his blood run cold. The entire rear section swayed and vibrated constantly. The single structural beam holding it was visibly flexing, bending slightly with each aircraft movement. The gaps between the severed section and the main fuselage were large enough to see through. Wind howled through the openings, creating noise so loud that communication required shouting even over the intercom. The fuselage skin was shredded. O'Neill counted over 200 visible holes just in the section he could see, knowing there were many more he couldn't observe. Some holes were small, barely larger than a finger, from machine gun bullets. Others were massive, the size of dinner plates, from 20mm cannon shells that had exploded inside the aircraft. How this aircraft was still flying was beyond his comprehension. By every rule of engineering and aerodynamics he understood, all Americans should be in pieces scattered across North Africa. Yet here it was, droning along at 160 miles per hour, staying in formation, bringing its crew home. At 15:45, 90 minutes after the collision, Navigator Dunleavy announced they were 60 miles from base. 15 more minutes. 15 more minutes of hoping the structural beam would hold, hoping the tail wouldn't tear free completely, hoping the engines would continue running and the wings would stay attached, and the aircraft would remain flyable just a little bit longer. Bragg began considering landing procedures. Landing would be the most critical phase. The aircraft was barely controllable at altitude with power on. Landing required reducing power, slowing down, descending, all while maintaining precise control. With minimal elevator authority and uncertain rudder control, landing would be extraordinarily dangerous. "Engel, we need to plan the landing," Bragg said. "We're going to approach at higher speed than normal because I don't trust the controls at slow speed. We'll keep power on longer. We'll aim for a shallow approach angle. And we'll plan for a long landing roll because I'm not confident in our ability to brake or steer on the ground." "Agreed," Engel replied. "We should also plan for the possibility that the tail section will break free during landing. If that happens, we'll have no tail stability at all. We might want to consider belly landing instead of using the landing gear." "Negative," Bragg decided. "A belly landing means sliding on the damaged fuselage. The tail section could dig in and flip us. We use the landing gear. At least then we have a chance of keeping the tail off the ground until we've slowed down." At 1600 hours, 105 minutes after the collision, Biskra Air Base came into view on the horizon. 150 miles covered in impossible circumstances, an aircraft that should have fallen maintaining altitude and heading the entire way through pilot skill, Boeing engineering, and what could only be described as stubborn refusal to acknowledge that physics said it should be crashing. Bragg radioed the tower using the co-pilot's emergency radio set, one of the few communication systems still partially functional. "Biskra Tower. This is all American. We've sustained catastrophic damage. Tail section nearly severed and hanging by one structural beam. We're going to attempt landing, but we may not be controllable. Request emergency vehicles standing by and clear everyone from the field." The tower's response was immediate. "All American Tower. Roger your situation. All emergency equipment is rolling. Field is being cleared. You're cleared to land any runway. Wind is light from the west. We'll be ready for whatever happens." At 16:05, Bragg began his approach. He kept power on longer than normal, maintaining airspeed, keeping the aircraft stable. The descent was shallow, afraid that any rapid altitude change would induce control problems they couldn't recover from. At 1,000 feet, gear down. The hydraulic system, damaged but still partially functional, lowered the landing gear. 3 green lights indicated the gear was down and locked, though Bragg had no confidence the tail gear was functioning properly given the damage. At 500 feet, the aircraft was stable. The approach speed was higher than normal, the descent angle shallower, but All-American was responding to controls, tracking the runway centerline. At 100 feet, Bragg reduced power slightly. The nose wanted to drop. Both pilots pulled back on their yokes, fighting to keep the approach angle correct. At 50 feet, all 4 engines at idle. The B-17 descended toward the runway, the damaged tail section vibrating and swaying in the airstream, held by a single structural beam that had exceeded its design limits for nearly 2 hours. At 20 feet, ground effect altered the aircraft's aerodynamics slightly. The pilots compensated, adjusting control inputs, working together to keep the wings level and the nose up. At 10 feet, the main wheels touched. The impact was gentle, barely a bump. Bragg and Engel held the nose up, keeping weight off the damaged tail for as long as possible. At 5 feet, the nose gear contacted. Weight shifted onto the damaged tail section. The structural beam flexed, but held. The tail wheel touched the runway, rolling along the concrete, supporting weight it shouldn't have been able to bear. Brakes. Bragg applied brakes carefully, feeling the aircraft decelerate, feeling it track straight down the runway despite the damaged tail. 1,000 feet of runway consumed. 2,000 feet. 3,000 feet. At 4,000 feet, All-American rolled to a stop. Bragg shut down all 4 engines. The sudden silence after hours of engine noise was startling. For long moments, no one moved. They had survived. Against every probability, against all logic, they had flown an aircraft that should have crashed 200 miles and landed it successfully. "We're down," Bragg finally said over the intercom. Everyone out carefully. This aircraft could still collapse. The crew evacuated quickly, climbing out through hatches and windows, gathering on the runway to look at what they'd been flying. What they saw made several of them physically ill. The damage was even worse than they'd imagined. The tail section hung at 20 degrees below normal, attached only by a 4-inch structural beam that was bent and twisted, but somehow still intact. Holes covered the fuselage. The ground crew would eventually count 600 bullet and shrapnel holes. The radio compartment was destroyed. Control cables hung severed. Hydraulic fluid dripped from ruptured lines. Electrical systems sparked and smoldered. The embedded section of Messerschmitt wing remained in the fuselage. Engineers who examined All-American over the following days were unanimous in their assessment. The aircraft should not have been capable of controlled flight. The damage was too extensive. The structural failures were too severe. By every calculation and every precedent, All-American should have fallen from the sky within seconds of the collision. One Boeing engineer who examined the wreckage wrote in his report, "The fact that this aircraft remained airborne demonstrates structural integrity beyond design specifications. The redundancy built into the B-17 design exceeded our own calculations. We designed it to be strong. We didn't realize we designed it to be nearly indestructible." Another engineer noted, "The single remaining structural beam was loaded to approximately 350% of its design limit. It should have failed. The fact that it didn't suggests our design margins were considerably more conservative than we believed." The structural analysis revealed several factors that contributed to survival. The bottom keel beam was constructed of high-strength aluminum alloy with cross-bracing that effectively doubled its strength. When other structural members failed, this beam alone carried loads it wasn't intended to bear alone. But the material properties and construction technique provided strength exceeding theoretical calculations. The tail section, though damaged and hanging at an angle, remained relatively rigid. If it had broken into pieces, the aerodynamic loads would have been uncontrollable. But the tail structure remained mostly intact, flexing but not fragmenting, providing some stabilizing force. The control cables that survived the collision were routed through the lower fuselage in protective channels. Most cables were severed, but the few that remained provided minimal control authority, just enough for skilled pilots to maintain controlled flight. The Wright R-1820 engines continued running flawlessly despite vibration levels that exceeded normal operational limits. The Engine's robust construction and the B-17's vibration-dampening engine mounts allowed them to function normally even with the aircraft's structure vibrating from damaged tail. Most critically, the pilot's skill kept the aircraft airborne. Lesser pilots might have over-controlled, inducing oscillations that would have stressed the damaged structure beyond its limits. Bragg and Engel flew smoothly, coordinating their efforts, making minimal control inputs, working with the aircraft's damaged condition rather than fighting against it. The crew of All-American received recognition for their achievement. Second Lieutenant Bragg received the Distinguished Flying Cross. The entire crew received air medals. But more importantly, their story became legend among bomber crews, proof that B-17s could survive damage that seemed impossible and still bring their crews home. The aircraft itself was beyond repair. The damage was too extensive for field repairs, and shipping it back to the United States for rebuilding wasn't cost-effective when new B-17s were being produced at a rate of 16 per day. All-American was stripped of usable parts, then scrapped. But photographs of the damaged aircraft were widely circulated, used in training materials to demonstrate B-17 survivability. German pilots who encountered B-17s in subsequent engagements remembered All-American. The bomber that kept flying after losing its tail became a cautionary tale about underestimating American aircraft design. Luftwaffe intelligence reports noted that American heavy bombers demonstrated structural resilience that exceeded German aircraft, that pilots should not assume combat damage would be immediately fatal. The broader impact of All-American survival affected bomber tactics and design philosophy. Air Force leadership cited the incident as validation of heavy bomber design philosophy. Build strong, build redundant, build for survival. The losses in bomber streams would be high, but if damaged aircraft could return even 20 or 30% more often due to robust construction, the operational advantage was significant. Boeing engineers studied All-American structural failure and survival, applying lessons to subsequent B-17 variants and to the B-29 Superfortress then under development. Structural load paths were strengthened. Redundancy was increased. Design margins were widened. All-American's story resonated because it validated a fundamental truth about industrial warfare. Engineering matters as much as courage. Brave crews flying fragile aircraft die. Brave crews flying over-engineered, redundant, tough aircraft survive. The B-17 was expensive to build, used more material than competitors, weighed more, cost more. But it brought crews home when other aircraft would have killed them. The statistical evidence supported this. B-17 crews had higher survival rates than crews flying other bomber types. Not because B-17s were shot down less often, but because when they were hit, they were more likely to remain airborne long enough for crews to reach friendly territory or bail out successfully. The survival rate difference was approximately 15%, enough to mean thousands of additional crews surviving the war. But beyond statistics and tactical advantages, All-American's story resonated on a human level. 10 men flew an aircraft that shouldn't have been capable of flight. They survived because Boeing's engineers had built their bomber stronger than they knew. Because their pilots were skilled enough to fly a nearly uncontrollable aircraft for 200 miles. Because the crew remained calm, worked together, and refused to give up even when physics said they should be falling. Staff Sergeant Joe James, the tail gunner who died in the collision, was posthumously awarded the Purple Heart. His body was recovered from the damaged tail section after landing. His sacrifice remembered as the price paid for the aircraft's survival. He had died at his post, returning fire at attacking fighters up until the moment of collision. The other 9 crew members survived the war. All completed their required 25 missions and returned to the United States. They remained in contact for decades after the war, reuniting annually to remember the day they flew an impossible aircraft home. At their 50th reunion in 1993, only 5 crew members remained alive. They gathered at the Air Force Museum in Dayton, Ohio, standing before a restored B-17, remembering their aircraft and their mission. Second Lieutenant Bragg, then 73 years old, spoke about All-American's flight. People ask how we did it. How we flew an aircraft that shouldn't have been flyable. The answer is simple. We didn't know it was impossible. We were 22 years old, trained to fly, trained to fight, trained to bring our aircraft home. The B-17 was damaged, but it was still flying, so we kept flying it. Only after we landed and saw the damage did we understand what we'd done. And by then, it was over. We'd already done the impossible because we didn't know enough to understand it was impossible. Technical Sergeant Zook, then 75, added, "The B-17 saved our lives. Boeing built that aircraft to be tough, but they built it tougher than even they knew. That single structural beam held up 800 pounds of tail section for 2 hours and never failed. That's not luck. That's engineering. That's American industrial capacity creating something so overbuilt, so redundant, that it exceeds its own design specifications. We flew it home, but Boeing built the aircraft that could be flown home." All-American story endures because it represents something larger than one aircraft's survival. It represents the philosophy that winning industrial warfare requires building equipment tough enough to absorb incredible damage and continue functioning. It represents the skill of crews who could fly damaged aircraft home. It represents American industrial capacity, creating machines so robust that they exceeded even their designers' expectations. The photographs of All-American with its tail hanging at an angle, held by a single structural beam, became iconic. They appeared in every post-war book about B-17s, in training materials, in museums. They represented visible proof of claims about B-17 toughness that might otherwise seem exaggerated. Modern aerospace engineers who study All-American structural failure and survival remain impressed by Boeing's design. Computer modeling suggests the single remaining structural beam was loaded to approximately 400% of its design limit during flight. Modern materials science can explain why it didn't fail, but engineers in 1943 didn't have that science. They simply built strong, built redundant, and hoped it would be enough. It was enough. All-American flew home. 10 men lived because Boeing's engineers had built their bomber stronger than necessary. Because pilots could fly when flying should have been impossible. Because a single structural beam 4 inches across held together when it should have snapped. 600 bullet holes. 11 German fighters. 200 miles to safety. And a tail held on by engineering genius, pilot skill, and pure refusal to acknowledge that physics said it should be falling. All-American proved that sometimes, rarely, impossibly, aircraft can survive damage that should destroy them. The bomber that wouldn't die became legend because it validated what every bomber crew hoped was true, that their aircraft would bring them home no matter what hell they flew through. And on February 1st, 1943, for one crew flying one impossible aircraft, that hope proved true.